Hello, I'm Carla Salinas, and in this video I'm going to represent my team to answer question 4 of our assignment. And well, here we have the instructions. It says that we have to record a tutorial to replicate figure 5.5 in Excel, in which you explain first how to replicate the figure, second, how should we read it, and third, how it helps us to make investment decisions. And well, let's begin with point 1, and this is the graphic we have to replicate. And we also have the data of that graphic. It says the information of two projects, Project F and Project G, and it also gives us the cash flows from 8 years. And well, also it gives us the internal rate of return of 36% in Project F, and the net present value at 10% is 4,921. And in Project G, we have the internal rate of return of 25% and the net present value at 10%, that is 6,005. And well, with this table, we have enough information to make the graphic. So what I did here is to do the same table with the data so I can use it. And well, then you have to make another table for the graphic. In the book it says that they use a discount rate from 0 to 55%. So we are going to do the same. Let's put the data. First 0, 10, 20, and so you go to 55. And then we are going to calculate the net present value. For this I'm going to use the formula that Excel has. It's NPV, that is net present value. And well, first you have to put the discount rate. In this case it's 0%. Then you have to put the cash flows. And in this case you have to put the cash flow 1, because we want to make these cash flows that are in a future value to a present value, so we can have all these ones in present time. And then I'm going to begin to select this, and you also remember to block the cell so it's more easier to make the table. And then so you go, you put the cash flow 2, then cash flow 3, then cash flow 4, cash flow 5, cash flow 6, cash flow 7, and cash flow 8. And then you have to add the initial inversion that is in the year 0. And you also have to block the cell. And then you select enter. And here you can calculate more easier the next data. Here is from 0 to 55%. Then we are going to do the same for Project G. You put the formula NPV, the discount rate, and then the flow cash of, here is the flow cash 1 of Project G. You also block the cell, and then cash 2, then cash 3, and cash 4, cash 5, cash 6, cash 7, and finally cash 8. And then we are going to add the initial inversion of 10,000. You also have to block the cell. And there you go. Here we have the information of the next discount rates. And well, next we're going to do the graphic. All you have to do is select the data. You insert a graphic. And here you have it. Next, so it's more similar to the one in the book. We are going to personalize it. Here I'm going to put the name of the figure 5.5. Well, then I'm going to put the names of the axes. First, the vertical axis, I'm going to put net present value. There. Next, I'm going to change this so we can see the 55. And we can delete this if you put this. And there you go. And well, here we have the graphic with information of the two projects. Project F it's the blue one, and Project G it's the orange one. And here we can see, for example, at 10%, Project G has a net present value of 6,005, and Project F has a net present value of 4,921. And well, with this we answered the point 1 of replicating the graphic. And next we are going to answer point 2, that it says how should we read the graphic. And well, from the graph it can be seen that the Project F has a higher internal rate of return compared to Project G, because here you can see the internal rate of return is when the net present value is 0. So you check this, and then it's the 36% that the book gave us in here. So the Project G has an internal rate of return of 25. If you put the mouse here, you can see the net present value is 0, so it's approximately 25%. And well, taking this criteria into account, it could be assumed that it's better to choose Project F and reject Project G. However, assuming the case in the book where a discount rate of 13.9% or lower is applied, then the net present value of Project G is larger than the net present value of Project F, and Project G should be accepted. And well, if we see the graphic, here we can see at the discount rate of 13%, Project G has a higher net present value and Project F has a lower net present value. From this point to 0%, it's higher the Project G. On the other hand, if a rate higher than 13.9% is applied, it is better to accept Project F, which has a higher net present value. Because if we see this part of the graphic, Project F, if F has a higher net present value, and Project G has a lower net present value. So well, this is how we can read the graphic. Next, we are going to answer the point 3, that it says how it helps us to make investment decisions, this exercise. And well, the answer of our team is The case presented in the graph is a clear example of how sometimes using only the internal rate of return to make investment decisions can give inaccurate results, while the net present value gives a value that is more consistent with the value of money measured over time, which help us to choose more easily those investment projects with a higher value. Because, again, considering the internal rate of return, we choose the project F. But if we consider the net present value that again is given in this part of the graphic, then obviously we are going to choose project G considering the net present value. So sometimes it can be a little confusing using the internal rate of return. So it's better if we use the net present value. And with this, we conclude the tutorial, and thank you for listening.